We'll continue our review for Test 3, the fraction part. For this problem, even if you did not have the word solve here, the special symbol in this problem is the equal symbol. This is not just an addition and subtraction problem. It is a solve problem. So you're going to work it differently than an add and subtract. For equations that have fractions, so we have an equation, we have fractions, what you're going to do is find the common denominator. What would be the common denominator for this problem? The 2 is over 1, so actually a 10 would work. Everything would go into 10. So our LCD is 10. With equations, what you're going to do is multiply by the 10 on the numerators so that the denominators will all cancel. And you have to do every term on both sides. So we're going to multiply everything by a 10. And we're doing it on the top, different than add and subtract. Add and subtract, you do top and bottom. You have to also do the term that doesn't even show a denominator. It has to be every term to be okay on both sides of the equal sign. So I have multiplied everything by 10. Now, I'm not really going to multiply it out because these with fractions are going to cancel out the denominator. This is really a 10 over 1. So my 5 will go into 10 2 times 3x is 6x. My next piece, no denominators to cancel, so 10 times 2 is 20. Bring your equals down. On the other side, the 10s will cancel, leaves us a 3. Now you have a plain equation. That's the nice thing about these equations. You can make the fractions go away. So now we will isolate the x. First, we'll take off the 20. Anything added or subtracted should come off first. The 20 is added, so we need to subtract it from both sides. This is what we had. We're going to subtract a 20. Bring your equals straight down. Bring what you had, and we're going to subtract the 20 on that side. It's like a scale. Keep it balanced. Leaves us 6x on the left. Different signs. Subtract, sign of the larger. Your next step on this equation is to divide out the coefficient. So we're going to divide by 6. Now that we've learned about fractions, sometimes we will get fractions for answers. This is a fraction. The 6 does not divide evenly into 17. So we're just going to leave it. Our x is isolated. That was our goal. Negative 17 over 6 is our answer. Problem 10 is also an equation. Notice the equals symbol. So it's an equation. It has fractions. We want to get rid of the fractions. So first job is find the common denominator. Check the biggest one. Will everything divide into 20? It will. So this time our common denominator is going to be 20. We're going to multiply everything on 20. Remember, we're going to put it on the top. So 20 times 2/5 plus 20 times x over 10. Bring your equals straight down. Multiply by 20 on this one also. 20 times 16 over 20. Now we're going to clean up. So we're going to cancel our denominator on each one. On the first one, 5 will go into 24 times. 4 times 2 is 8 over 1, which we don't care about in the denominator. The next one, 10 will go into 22 times. 2 times x is 2x. Bring your equals down. The third one, your 20 will cancel, leaves you 16. Now you have a plain equation with no fractions. You're going to isolate the variable, work on the side with the x. So first you need to take off the 8. It's turned around a little bit, but whatever's added or subtracted. So the 8 sign's in front of it, positive 8. We need to take it away to make it cancel. So we're going to subtract an 8 from both sides. Remember, your equals separate your sides. So there, that's starting our other side. Now we want to subtract 8 on that side. Keep it balanced. Clean up. 2x equals 16 minus 8 is 8. Go back on the side with your variable and you're ready to divide out your coefficient. So we need to divide by 2. This time it works out even. So 2 into 8 will go 4 times. So x equals 4. I'm going to switch gears here a little bit and go to mixed numbers. So we are multiplying mixed numbers. To do that, you have to change your mixed number to an improper fraction. So we need to do that first. Remember, you do whole number times denominator, add back the numerator. So 2 times 5 is 10, plus 4 is 14, goes back over the original denominator. Do the same for the other one. 2 times 8 is 16, plus 5 is 21, goes back over the 8. Now you have regular multiplication of fractions. Remember, we've switched now. Adding and subtracting is where you need a common denominator. Multiplying, you do not. Multiplication is where you can cancel on the diagonals if there's any common factor. There is nothing with 5 and 21, so we'll leave that one. On the other direction, 8 and 14 are both even, so you could divide by 2. 2 will go into 8 4 times, and 2 into 14 will go 7. Now we will multiply across. 7 times 21 will give us 147. 5 times 4 is 20. I would accept that answer. It's not going to reduce. But since you started with mixed numbers, in the back of the book and on the computer, they will want you to go back to a mixed number, since that's what was there to begin with. So to take it back, you divide it out. 20 into 147, and you're going to have to go all the way into 147. 7 times will give you 140, and 7 is your remainder. It goes back over the divisor. So either 147 over 20 or 7 and 7/20. Those are equivalent answers. Next we have a division of mixed numbers. Just like multiplication, you have to change to improper fractions first. So 5 times 5 is 25, plus 1 is 26 over 5. It's still division. 3 times 4 is 12, plus 1 is 13. Goes back over the 4. Right. For division of fractions, remember you change to multiplication and invert the divisor. So first fraction is going to stay the same. We're changing to multiplication. Second fraction is going to flip over. Once you're in multiplication, you try to cancel on your diagonals. There's nothing with the 5 and 4. On the other diagonal, we actually have a common factor of 13. So we can divide by 13. 13 will go into 13 once, and into 26 it will go 2 times. Then we can multiply across. 2 times 4 is 8. 5 times 1 is 5. 8/5, I'm fine with that answer, but we will divide it out to get the equivalent one. 5 into 8 will go 1 time, with 3 left over. 3 will go back over your divisor. So 1 3/5 is an equivalent answer to 8/5.